We are going, respected participants, we are going to start the third technical session, which is about the hydraulics and hydropower engineering. I will be the chair for this session, and I am going to invite Dr. Atiku-ur-Rehman from Melbourne, Australia, for special lecture. And before that, uh, I will introduce Dr. Atiku-ur-Rehman. Dr. Atiku-ur-Rehman has done his PhD from TU Delft, the Netherlands, and he has worked in many countries in Europe, Asia, and Australia. And he has more than 15-year experience in academic. He has served as HOD in COMSET and CUST, and he has published number of papers, more than 40 journal papers in international journals, and he is also editor of many international journals. Now I will ask Mr. Atiku Rahman, please, uh, uh, please, over to you. Please, you can present now your lecture, Dr. Atiku Rahman.
Thank you very much, sir. Thank you. I just want to make sure, I will have a number of my co-partners. So just want to make sure, all of my co-presenter have access to mic, or we need to request them, especially. Um,
Excuse me, Dr. Atiku Rahman, your voice is bit low. Please, can you
not
check?
not very clear, sir. Can you hear me now?
No, 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 it is okay.
Great. Great. I have my team members who will be joining me. I just want to make sure, if they can also enable their microphone.
Yes, sir, we are able to enable
Great.
microphone.
Great. Thank you very much. Thank you. So nice of you.
Yeah, I
Uh,
can also hear you.
Thank you. So I'm going to present over multidisciplinary work on the emerging role of water governance. And for this, I have my whole team with me. I would like to introduce Dr. Saira from Capital University of Science and Technology, Muhammad Hizar from University of Louisiana, Zohreh Rajabi, Paras Sidique from Deakin University, myself, and Dr. N from CDU. We have been doing, as I mentioned, multidisciplinary, not only engineering, where we are going to the peak of our engineering professional, but we are trying to involve all the disciplines which can support us towards the water governance. As I mentioned, water governance is demanding the inclusion of all the aspects. The major perspective and reason was, we engineers are very good in millimeters and very accurate and precise, but our policies, our decisions, those are not implemented because of a break between the policymakers and the engineers. So that is why we develop a multidisciplinary group, which is covering the political, legal, hydrological, water issues, policies, everything which we are covering. So we just want to make sure we are going to be efficient, effective, and we have the trust because of the engagement. I would explain few of the project where we already have published our work. One was the hydropolitical issues of Pakistan, internal issues, and the cross-border issues. That paper was published, and the project was also again with the whole team, and then the similar study was done for. Um, uh, Nepal, and then we have gone through then the role of the water governance in terms of flood risk management, insurance inclusion, and everything that was done with one of my study as my last incident. So I would request Zohreh Rajabi, she have been doing excellent work in virtual water trade and water footprint. She can take over from there. Are you there, Zohreh?
Can you guys hear me?
Very, very low. Can you be a little bit louder?
You guys hear me now?
I think not very clear. Can you try to see if you can be louder, please? Shaisab, can you mute yourself, please? Maybe then she could be a little bit louder.
Can you guys hear me better now?
Wonderful. Over to you.
Okay. So it was a bit of technical difficulty. So, so in the past decade, I can say we have noticed new trends that a lot of publication research has been done on it, including mismanagement of our water usage. Our population, our rapid population growth, climatic disturbances to our water resources that we have available. So that has put on a strain on what our water, it has affected our water stress as well. So this section that I'm talking about, it's mostly affecting in terms of water governance, is affecting the capacity, innovation, and monitoring and evaluation. So I'm not sure. I don't have. Okay, so so for us to understand this topic better and have a better understanding, we need to have a histogram of development over the historical era. So we have to have a better understanding of water resource management, and we have to have a better understanding of water consumption, including different sectors, including agricultural water use, industrial water use, and domestic water use. So there are a lot of modern approaches of water resource management, including water footprint, water recycling, consolidation, fog catchment, and more. That you can see on the screen, obviously, and you have heard of most definitely. But can we move on to the next slide, please? Yeah. So one of the topic that Ma mentioned is water footprint. So water footprint, by definition, it means the amount of fresh water that is used either in supplying or production of a product. So we have done a research previously on water footprint within Australia, and we looked at different sectors. So agriculture sector was one of the sectors that has the highest water consumption, and it has the highest water footprint. But in terms of trade, one of the products that we trade mostly, export mostly, is beef. So in 2016, Australia consumed the seventh. It was one of the countries that, one of the top countries that consumed beef in 2016. We consumed around 717 million kilogram of beef in just 1 year, and 1 kilogram of beef was almost 15.5 thousand liters. So that equals to using 11 trillion liters of water, and that's just a small example. And another thing that we have to look at is that the methods that are mentioned in the previous slide are not uh, which are known as conventional methods, but are not able to cope with the current situation that we have. So the water footprint is needed because it provides a systematic approach. So it will enables you to look at different criteria and different stuff that is needed, including economic, availability of your water, and more. Can we please move to the... Okay, so the first, as I mentioned before, the first thing that we looked at, or you need to look at, is agricultural water footprint. So we need to have a better understanding of agriculture activity, the climate change of any area that you choose, and the current water scarcity and water stresses. So you have to have a very good understanding of what's going on and what the situation is to be able to calculate the water footprint of a specific crop. So there's a lot of data that needs to be collected for you to make the analysis or do the calculation that is needed, and that includes blue water footprint, irrigation method, and more. And we need to have a better understanding of what other adaptation techniques are available out there, including policies and frameworks, selecting adaptation choices, and making the adaptation choices. The second part I wanted to talk about is water footprint of hydropower. I know in your institution you guys are very active on hydropower, but we need to have a better understanding of water footprint in hydropower, types of water footprint including green, blue, and gray, and significance of water. So we have throughout our research, we have looked at water consumption in energy production, in global scale, Australian scale, and Victorian scale, obviously. And we have looked at influential factors, including sensitivity to an area, sensitivity based on region, comparison between dams for water efficiency, and variability based on change in temperature throughout the year. And as I mentioned in the previous slide, water footprint is very new, and there is a lot of aspect that you need to take into consideration. So you can't just use one formula and say, I'm going to use this formula or this model, and I will be able to do the calculation. So you need to have an understanding of approach-based water footprint assessment, sector-based water footprint assessment, and water type-based water footprint assessment. So you can choose the right calculation method for the situation that you have or the condition you are in. So I hope you enjoyed this section, and I pass it to my next teammate.
Yeah, ma'am, Saira, kindly. Ma'am, Saira.
Yes. Yes, can you hear me?
Yeah, clear.
All right, thank you very much. That was very well presented by Zohreh. A very good morning and good afternoon to all participants. I'm very honored to be part of this event, and I'd like to present the section on water policies. We are currently working on water governance with regards to three main aspects, particularly the efficiency, the effectiveness, and the trust and engagement components. Similarly, we do know that this is very interdisciplinary, as Dr. Atiq rightly so mentioned in the beginning, and there are certain aspects that need to be covered, particularly with regards to regulatory frameworks, innovation, integrity, and transparency. Then a very important area with regards to the management, water management, pertains to stakeholder engagement, the trade-offs across the various users, clear roles and responsibilities that need to be defined, along with policy coherence and monitoring and evaluation is indeed very important. So we are looking into nexus problems with regards to water, food, and energy security, and we have action fields, as you can see in this diagram on the right side, which are under the category of society, economy, and environment. And these action fields feed into the nexus problems, and which are then affected by urbanization, population growth, climate change, and of course the global trends in a post-COVID world. And similarly, the outputs include governance, which is of course very important because it gives you the enabling environment, and innovation, which is ultimately going to promote the water, energy, and food security, along with equitable and sustainable growth towards a resilient, productive environment. So, all in all, a water policy, of course, is very comprehensive, and we aim to see transboundary issues as well, which are sometimes hampered by the trust issues between interprovincial and interregional designs of the water policy. So we are seeing at the bankruptcy theory, the national and international transboundary issues. Then we are also looking into water demand along with water sharing and water availability. So that's my portion. Thank you very much.
Thank you very much. Thank you. Ma'am Paras, kindly, can you?
Yeah. Assalamu alaikum and hi to everyone. So I am basically working in field of remote sensing and GIS. Remote sensing and GIS offers a great, like it offers us uh, uh, process the data more deeply using the programming and other tools which GIS has to offer. And remote sensing has remote sensing gives us the freedom of choosing the data, because through remote sensing, when we are talking about remote sensing, it's mostly satellite data or airborne, spaceborne satellite, spaceborne data, and these data sets are usually available in archives, and we can go back in time as well. So there are different satellites that are available at the moment for hydrology applications or land surface temperature or atmospheric applications. And these data are processed using the most advanced tools available in GIS, mostly using the programming interfaces like Python and Google Earth Engine or R. And as you can see on this slide as well, I'm showing few of the images captured from the satellite and processed in these GIS tools. And there are other satellites as well. So this satellite data is about land surface temperature, but for moisture and hydrology, there are other satellites available. For example, GRACE satellite that can measure the groundwater. MODIS, it is also widely used in hydrology applications, and there are other satellites as well for monitoring soil moisture and other applications. So in a nutshell, I would say that this specific application is more like a tool to evaluate or to analyze the application, to analyze the problem statement in environment or other applications. So that's all from my side, and I'll pass to next
Thank
um,
you. And
speaker.
thank you. So nice of you. So nice of you. Thank
Thank
you.
you.
So like, I mean, with this collaboration and, multidisciplinary collaboration, we have done quite a lot work in quite short time, good number of papers. So, I mean, I would request Dr. Ann to, explain a little bit what kind of collaboration opportunities we can have with the participant here, particularly in this conference. Over to
Yes,
Dr.
thank
Ann.
you. Yes, thank you, Dr. Atiq. And thank you to our team for presenting our multidisciplinary research in water resources. As you can see, without funding support or without collaboration, all this research cannot happen. So the key of our team is to develop and expand our international linkage. And this is only one aim, is to have capacity building. This is very key to attract funding so that research can continue. So one of our key is to collaborate on projects, international projects, and to build up our track record so that we can have more funding. We can share our resources, including softwares, hardware, lab facilities or virtual lab facilities. And also we can invite for special issues ranging from 20% to 100% for our APC, which we can waive for quality papers, high quality papers. Our team has 3 current Q1 special issues. As you can see here for the water, focusing on innovative approaches to sustainable water resources management, under population growth, lifestyle improvements, and climate change. The second one is sustainability in MPDI, sustainable approaches to reduce building energy consumptions. And the third one is in the water of MPDI is the urban green and blue infrastructure, current issues, challenges, and opportunities. So these are our current 3 Q1 special issues that our team is co-editing. And we have, through this collaboration international, we can have mutual supervisions with students, combined projects and publications, and also student engagement programs and other research opportunities as well. So looking forward to expanding our network and to build a very strong capacity building for future funding. Thank you.
Thank you very much, Dr. N. Guys, like as Dr. N mentioned, like, we have some resources because of, this collaboration. We are very happy to extend all these collaboration to our participant in this conference. As mentioned, like, we can offer up to from 20% to even 100% of APC discount, which could be something attractive for over participant. So I'm really thankful to all of you for listening us very patiently. My email is like Atiq.Tariq at Gmail or Yahoo. So I mean, you can just send me an email, or if you have mobile, you can scan this code and you can get our contact details very quickly. So I would thank all of my co-presenter for their time, and I mean it is actually a little bit late here in Melbourne around 9 p.m. and one of our participants couldn't join because it was 2 a.m. in America. So we requested him to drop. Once again, thanks to you, panel chair, Dr. Shahid. If there is any question, please.
Thank you very much, Zohra, Saira, Paras, and Dr. Anne, and Dr. Atiku-ur-Rehman, for your valuable contribution, multidisciplinary water governance. And now I thank you very much again